G'day guys. Okay, I wired up this 5000 and I've got it sitting in here, and I'm just going to grab the microphone and move it over near the speaker. If I move, hang on, there's boxes and stuff in the way, but I will stick it over here. Where is the speaker? There it is. I don't want it too loud, but I'll stick it like that. Okay, that's the detector running in normal mode, normal settings, and you can have a look. It's basically got the modified boards in it, and all the other little mods and sods we do. Yeah, there's that wiring, as you can see. It's basically, well, we'll call it a double transmission line turned into a transmission line. But doing it the way I've done it is the best way to do it. I've tried everything. I've tried trying to separate the transmit from the receive. I've tried to run separate filters, cores, all sorts of stuff, every configuration known to man. And no, put it all together, do it the way I did it in the previous video, and that's what you're going to get. And at the moment we've got this on. Oh, the wire, where is it? Oh, I've got this thing. Oh, there it is. It's a big 11-inch coil. So at the moment it's running on an 11-inch coil, and if I find a target, give you an idea how quiet this detector is. I don't want to go, oh, here we are. How about we just give it a whack with the 0.1. Gee, that's a bit close up, but yeah, maybe I shouldn't zoom in that far. That's better. So 0.1. Yeah, I haven't got a mic on me. I hope you can hear me, but that was a 0.1. And yeah, it's a little bit of burble. It's in the middle of suburbia, of course, with all the noise. I'll give it some hot rock treatment. Hang on a sec. I'll make this straight and I'll wind this up in the air. It's got a winder on here somewhere, so we can get it up. I'll get it up high. Yeah, up the elevator. There we go. And lock it there. I'll leave the microphone near that speaker so you'll be able to hear it properly. Okay, let's make sure. Let's go from fixed into tracking. I'm probably not quick enough, but we're in normal mode, so give it a quick flick. That's in normal mode. It's basically getting rid of that horrible Kalgoorlie solid ironstone lump. So, most detectors standard have a hard time getting rid of that, but if you want to make it easier and cheap, you get the smaller Kalgoorlie hot rock, which is that one. These are very rare to find, except in particular areas over in WA. There's can be some quite a big amount, but as shape changes, you're going to get a different signal response. So we'll just flick it into fixed, back into tracking, and basically gone. So get rid of those. easy. Like I say, I'm in normal mode. Normal. People don't prospect in normal mode, right? Because they're scared of these things. Another hot rock. We'll just flick it again. That's more of a normal type of hot rock you'll get. The other things are just basically pure ironstone. This is it's an ironstone rock, but it's not solid iron like those other things. This one, eat it for breakfast. And like I say, it's normal mode. It's not fine gold or enhance or anything like that. So, and it's running factory gain. So, yeah, you can do a lot of work on these detectors to make them better, as you can see. So, yeah, that's a 5000. 5000s are particularly noisy too. They compared even the 4500 version, which is basically a 5000, a few bits left off, and values changed. But the very old first edition 7-digit serial number 4500s are far quieter and more punchier than the later 4500. It's noisy in the other modes. It really gets up and chirps away, especially fine gold. Fine gold can get quite chirpy on a 5000. So yeah, but that's running quite nicely on the workshop bench, and it's not too bad. Anyway, I hope you heard me over the detector. So I'll grab the microphone back, turn it off, turn off the booster, and I'm going to go and have some dinner. But anyway, that's that. The previous video will explain how to do this wiring, like so. You just want to put it, when you put it back together, you want to tuck this in here, in a little pocket area, just in where the capacitors are. And if you want to get really pedantic, you could, I should show you this too. I might as well show you this while I'm here. I just remembered. I'll turn it back on. So, okay, you can hear it. Now, I don't know how many of you guys have gone and grabbed your detector and touched around the cable and it goes off. Like touching here and it goes, whoa, whoa. Or bend your cable and it goes off. Have I got that in screenshot? Yeah, I have. I'll just move it around a little bit more. But now I'll put the microphone, running out of hands. There you go. I'll put the microphone there. But like I say, it's running factory settings. Now, how many of you, not even the case on, right, which makes it 10 times more volatile. But if I grab it and it's probably more that happening than the cable. By doing this, what I've done, you do this transmission line technique, the detector is nearly immune from grabbing the cable and wiggling it around, okay? So that proves something, doesn't it? It's less affect anything sort of external to the detector, just making noise. The biggest test is, now if you get a detector, any of these things, and you stick your fingers on those wires, the detector will scream. It'll go, wah, carry on like a pork chop. Well, hardly anything, okay? So it gets rid of all the stray interaction with surroundings, and that's why we call it transmission line. I mean, if I stick my finger right down where the damping resistor is, it'll probably make a bit of noise. Oh, I'm touching the transmit output little tank circuit here, which will definitely make a noise from touching the windings. But if you touch around the input, it's minimal. Usually it'll sound like a target. It'll go, ah, scream at you. So, but just tapping it like that, hardly anything at all. I'll push that down. That's better. So that's how these things should be. So you got to remember, if they usually glue the big ferrite to the board and holds it all stable, but some detectors, especially GPs, it just banged around in there, hanging by the wires. So I've got to. Well, basically, I can show you. How about I show you? Seeing's believing. If I go down here. Okay, that's a GP, right? And this is how the inductors were done. There you go. They're just floating around. I'll unzoom that a bit. But yeah, that's an old GP, and that inductor was just squashed in here somewhere. It was just squashed in there like so. But if you bang around, make noise. But anyway, live and learn. Yeah, but yeah, like I say, I suppose from the first detector, which was the old, what was it, Gold Seekers 15,000, detectors have come a long way, and things don't bang around and wiggle around as much. But yeah, that's quite good. And even though it's just sitting there, factory default settings, on we'll get over here on this coil, and I'll just show you. Even using a big coil, I'll get a tiny target. Here we go. We'll get that 0.0025, not 0.25, 0.0025. But this is with modifications done on the detector as well. But it's sitting there purring away. You can hear that all right, I hope. That's in normal mode. You know, it's not meant to pick up stuff like that. But yeah, that's how it works. I mean, I don't even know where I am in the frequency range. I put variable frequency on this too, by the way, this detector. Now let me have a look. Oh God, it's at the bottom end of the frequency range. How about we go and stick it right at the... I'll show you something. So just so you know, this is at 62. I'll wind it right up. We're up at 255. And, okay, I'll just turn that up so you can hear it a bit better. That's flat out the frequency. That's running pretty fast. And there it is. Just give you an idea of the 0.0025. What sort of difference that it makes. I keep forgetting, someone who watches my videos hates it when I do that. So we'll do that. Yeah, about there. And like I say, it's on normal mode. So that's why you put variable frequency in these detectors, so you can crank it up, and it basically gives you 255 adjustments. And if you can't get rid of the noise in a couple of clicks either, there's something wrong. So you can stay at the top end. Like you go anywhere between, say, 255 down to about 230. It's much the same, and it gives you all that range to tune out if you've got any repetitive noise in that part of the spectrum. So yeah, there you go. That is one modified, nicely working 3500. I'm pretty sure. Sorry, 30. What did I say? I picked up the 3500, so I said 3500. It's actually, yeah, it's three of people's addresses, but hang on, got black tape on it. Oopsies. He's not getting his detector back. I've got rid of the address. My God, there you go. It says 5,000 on it. Gee. Oh, dear me. That's all right. Didn't stuff his address up, so he will get his detector back. But yeah, I'm just checking on the box. Again, this is got the earthing done here, the grounding. It's got the paint removed, and nothing. Again, floating front, which can cause noise. So yeah, there you go. There's no grounding to the front plate that goes on here. In the last videos, I've said screws that touch into the metal here do not touch the plate, and it's got a rubber gasket. So it's just basically a few picofarads of capacitance for its earth coupling, which probably with a low frequency device isn't really good enough, in my opinion. See, everyone thinks I have a go at Mind Lab. I don't really. It's just you know, I've just been doing this for so bloody long. It's just know damn well. But you know, I know engineers who do analog, or try and do analog, but they're very good at digital. But they don't decouple the ground planes from the digital domain into the analog, and it sits there and puts that all up the analog. I've seen that. I just shake my head. But anyway, there's techniques you've got to do that keep everything nice and quiet. They've done some good decoupling in the power rails for the front end of these. They do have on these ones a version of a capacitance multiplier, which just use a couple of bipolar transistors and some fairly substantial capacitance on the base, and that then controls the current flow through the device, and because of that heavy capacitance, keeps the rails nice and steady. You put another bit of capacitance around it too. You can also add a little bit of series resistance to give it a bit of a voltage drop, so the capacitors really knock out any lumps and bumps in supply. So, but yeah, on these, a lot of these, they still tend to use inductors. But yeah, I flick the inductors out and put in very small value resistors, because if you actually go and have a look at the output from the inductors into the low level, if you can get down into the millivolt range with your oscilloscope, you'll find lots of noise and jitter. And by doing a resistive, basically, well, just resistive resistance, it does burn up the small transients actually in the resistance, and the capacitance. By adding a resistor in series to a capacitor, the impedance of that capacitor looks a lot larger than what it would be if it was going through a inductor, and also inductor and capacitor in some cases can make a tuned circuit. You don't want to do that, so you can use the inductors there, and if you really wanted to make sure that there's no funny business going on, you could put small, say a 10 ohm resistor across the inductors and run some extra capacitance. It's all about low frequency return paths and stuff, and a lot of these devices, in my opinion, it seems to be lacking. But anyway, we're not going to give away all the secret sauce and all the little secrets of making detectors nice and quiet, are we? The next one to work on is going to be getting the noise out. Well, I actually did get a lot of noise out of the 6000s. That's internal coupling noise, but I've got some parts coming, and I'm going to have to buy myself a 6000, which I'm still trying to hunt up. I want to buy one second hand. I don't want a new one. I want one out of warranty. I don't want a warranty unit because once I work on it, bloody warranty is useless anyway, isn't it? Really, because I'm going to pretty much extensively modify it, and I've got a lot of ideas to do. So, out of warranty ones, no problem. And I'll tell you something, guys. What I've heard from people. This is just my opinion again, right? So, you know, those lawyers get off your computers. My opinion. Anyone who has one of these detectors, not one of these are easy to repair, but anyone who has a 6000 uh, or even a 7, things that have those black modules in that uh, basically negate serviceability from anyone outside of my lab. I don't even know if my lab replaced those modules. I think they just rebought it, the whole thing. But see, out of warranty, and if your detector, that module, which they have done, they let smoke out and catch on fire and all the rest of it. Well, they don't catch on fire, but they let smoke out and they get red hot and they shut the detector down, all sorts of stuff. What happens with a 7, that after its warranty period, that happens and you throw it into the company to get repaired, and they say, "Oh, $5,000 for new boards, please," or whatever they are. I've been told some of this stuff, and the latest one I heard, I actually got it today, was a fellow was saying that he's out of warranty 6,000, basically stuffed up, and he sent it in to get repaired or a quote, and he refused to have it repaired because it would cost so much. So that's the downside of having sealed modules inside electronic devices. It really stuffs up the serviceability. Things like the microprocessors and CPUs and stuff like that hardly ever go wrong. They are so, it's like saying, well, your laptop blew the processor, or whatever, desktop blew the processor. It does not happen. Everything else blows up, but not those CPUs. Those things are pretty robust. So, you could probably always say that, that part of it is going to work more or less forever. I've only ever found one dead CPU in my whole life. Would you believe? I'm not joking. And that was caused by inductive spikes blowing it up. That's another story. That was to do with stuff on forklifts, electric forklifts. But yeah, please stop putting modules in things. make things serviceable, because if you get people like me saying to the public, this is your end game result after a certain amount of time, and you're going to get a bill of $5,000 or something, people will start going, "I'm not buying that." They will not buy it. It's terrible if you can't repair the boards. So I don't know. It's just my opinion, but I don't like it. And look at this thing down here. I know what all the chips are. I know everything on it. Oopsie, those things there. Um, they don't stuff up. They're Hitachi what are they, Renesas devices now, and never have a problem. I've had them with the legs coming off, and I showed in a video how to do a reflow on the legs, fix the detector. But black modules, it does. It's really, look. Maybe they put it in to try and stuff up the counterfeiting or something of that nature, but they're FPGA chips. You're not going to get through it in a million years. You're not going to be able to back engineer it. So, dear, I could go on and on and on, but I won't, because I won't make any friends if I keep going on and on and on. But yeah, I wonder if MindLab will sell me a cheap 6000. I don't know. Hmm. Uh, yeah, I don't know. Well, I want one. Hey, if I get one, I'll be able to do things. I'll be able to, promote your product. Awareness, because they're they're not a bad detector. They perform. They're a little bit noisy, and everyone knows that. But I'm 100% sure. I know I can quieten them down, but I can do it um, in part of the electronics on the detector as well. I can quieten the things down. So yeah, probably better to have people work with you than against you. That's what I say. So yeah, I mean, I could just go out and buy one. It's no big deal. I can go and buy 10 of them if I really wanted to, but I don't. But yeah, I would like to get my hands on one as my own. Like I have a 7000, but as work continues, if you look down there, there's a 7000 down there. So yeah, a lot of work's been done to that, and component changes and everything, and it's for the betterment of the operation of the detector. It makes a better detector. Hey, mind loop, just if you want to scratch my back, I'll scratch yours. I can say, like, your next model, don't put that in there, put this in there. There is a benefit, but usually crickets. Don't hear anything from anybody. And I always said, if anyone's got the balls, uh, if you want any of your stuff tested, I'll test it for you. But no one ever takes up the challenge. I wonder why. Oh, I don't know. Because I'll tell it as it is. I will not BS around the bush on it. I'll say it as it is. So, yeah, usually scares everyone away. There's usually some sort of defect in there, but yeah, I'm being pedantic now and waffling on, as people say. Um, yeah, that's what the fellow over in New Zealand says. He says I waffle on a bit. Yeah, I agree, I do. But you got to put content in these videos. I could stop, start, and edit it and all that, but no, it's quick and easy to do. Gets the information out there. You get a bit of extra info chucked in on the videos as well. Maybe it's useful to you. Maybe it's useless. Doesn't worry me. But yeah, I just make these. It's just an awareness thing, Um, we make headphones, we make batteries, we make boosters, we do all the detectors and upgrade the whole lot. There you go. There's some awareness. That's what we do. Uh, you know, even 7000s and 6000s, you work on them all. Don't have any qualms with it. But yeah, just so you know, that's what we do. And by the way, I'm getting a lot of really good feedback on our super duper duper headphones. You can go check out on DetectorMods.com. Yeah, super crisp and cut out all the rubbish. Yeah, I should have really, well, I did make wireless ones, but I didn't go through with it putting them out there. I just made corded ones. The reason being is my sort of tentative aversion towards anything Bluetooth near these detectors. There could be, I'm not going to go and give away, I can't go and say how you could actually fix any problems with Bluetooth with the way these work. There is a way of doing it, but I'm not going to go and say it. But if you really want to find out possibly how it could be done, go look at our patent we've got out there. Yeah, so yeah, you can use my name, you'll find it. But anyway, there's a lot of things to take into account. Anyway, I better go and do what I've got to do. And yeah, anything you want to know, always ask. Comment section. And as they say, I don't care if you do or you don't. Subscribe to the channel, or don't. I don't care. You know, people put up little subscribe things. I haven't got one on mine, have I? I don't know if I have or I haven't. It doesn't worry me. But yeah, all the dribs and drabs of money that come in from these videos for you putting up for these painful advertisements, or as the Americans say, advertisements. Well, whatever's right, I don't know. Yeah, it allows me to just buy some different componentry I would not normally buy and just try it, because I've actually had some really good wins with stuff. So yeah, there's a lot of bits and pieces that go and spend a couple $100 on different chips and whatever else and try it. I've got some stuff coming in from Mouser at the moment. I'm just waiting on it to come. Yeah, complete new stuff. Can go on any of these detectors, but we'll wait and see. You've got to make up some little boards, as you can see. That they actually went and got some that stuff there, ammonium persulfate, so I can etch some little test boards rather than keeping the Chinese industry going like I've been doing. I've got a whole heap of little copper boards. I just use black texture and etch my own boards just for quick tests. So that is cheap and easy. And yeah, we'll leave it there. And that's a video, half an hour, good enough. And yeah, my door's going to open. Someone's going to say, come and eat something. Anyway, catches.